Hey class, I wanted to give you a little overview of section 9.2, which is all about solving quadratic equations using graphing. Now, since graphing is such a huge connected topic to this section in the chapter, I wanted to show off a little bit of what the Desmos grapher could do because it's pretty stinking awesome. So what you see right here, the Gus Gus the Mouse image is an image that a student made using a whole bunch of different functions linked together with different colors and using the restriction on the function, just like what you guys were doing practicing marble slides. So I wanted to show you one that connects to what we've been learning. Notice over here at the left, we've got eyebrows, belly, nose, and it tells what types of functions were used to create the image that we see over here. So I'm going to open up the folder holding the equations for the eyebrows, and you can see, notice the squared, the y equals, and then there's a stretch factor here, and the part that is shifting it, and if I scroll this over here you can see a little bit more of it, but in the curly brackets, that's the part that shows where the parabola starts and stops, and notice it's negative, so that's telling me that it's an upside down parabola. It says that it's its eyebrows. So if I turn one of these off, notice one of the eyebrows is going to disappear. See? Oh, yep, this one, the one on his right eye, from our viewpoint, our right is gone, and then I turn it back on and it comes back. So that's parabolic right there, or quadratic. We've got the nose, the eyes. Let's see. I could see some more parabolas on the eyes. Let's take a look at that one. It's done in purple. So if I turn the purple parabola off, his left eye disappears. Turn it back on, and right. So that's an example of, once you learn a lot more about more functions, you too could make drawings like this in a grapher. So back to 9.2 specifically, again, this lesson is about solving quadratic equations using graphing. So if I was going to solve something like an equation that said, say, 0 equals this function here, then I would solve it using graphing. So where we find the zeros of the equation, or the x-intercepts, or the what are the other, let's see, the roots, the x-intercepts, or the zeros, or the solutions to the equation, they all kind of connect. So if I made the y equals 0, here is a place right here where y is 0. Notice x has a value of 2. That's the spot where it is on the x-axis, and the y is equal to 0. And over here, the x is -1 and the y is equal to 0. So those are the solutions, or roots, or x-intercepts, or zeros of this function. They all end up being the same value. So this is an example of where this quadratic function has 2 solutions. Notice 1, 2. So here's another example. Let's turn this one off so we can focus on this new one. Okay, so where does it touch the x-axis? Where is the x-intercept? Right there. Only one spot. So this is an example of a function where it's possible to have only one solution. The 0, where the y is equal to 0, the x value is -5, so the value of x is -5. And if I were to turn on an example with 0 solutions, here is one. There are no solutions. There are no places where my graph touches the x-axis, so there are 0 solutions here. Now, one thing that I want to point out that's kind of interesting, if I go back to this one, remember, if we make the a value negative, it does a reflection and flips the parabola down. So if I put a negative here, Notice that that function has flipped over, and now it no longer crosses the x-axis, so this equation just changed that little bit, would have now no solutions. Okay, so one of the things you're going to be asked is to solve problems like what we see right here. So it says solve x to the power of 2 plus 7x equals negative 10. Now there's going to be in section 9.2 two different methods that you could use to solve this. And both of them are using graphing. Now in the last chapter we practiced lots of different strategies for graphing, and so this is where you apply that. Now I would recommend playing with a digital grapher. We have technology, so using Desmos. So you're going to use Desmos a lot on this assignment, please do. So one method is to rearrange this. Currently this is not in standard form. There are 1, 2, 3 terms, and one of the terms is hanging out over here on the other side of the equation. So I want to move both of the terms to the same side of the equation by adding 10 to both sides, and that's going to give me x squared plus 7x, so just like what I had, and then if I add 10 to both sides, that gives me plus 10, and that equals 0. Okay, so did some funny things over here on the right. Now if I change it to an equation by putting my y equals over here, y equals, and I'm going to get rid of that 0 equals because, oops. Oh good, it did an undo. Yay. Okay, so get rid of that. Ta-da! Here's the parabola that is represented by that equation that we were asked to solve. So what are the solutions, guys? They are right here. One of them is -2, and the other solution is -5. Those are the solutions to that equation. Okay, you're going to be faced with a second method for doing this. We're going to see that we end up with the exact same solutions by doing that. So the second way is to make a graph out of each piece. I'm going to take this first piece and make an equation out of that, put that in. I'm going to start with y equals, so y equals x squared plus 7x, oops, plus 7x, there we go. Notice it made the graph, it's blue, it's right here. Okay, but I can't ignore this -10, so I'm going to make an equation out of that as well. Y equals -10, and graph that. Okay, so in my screen, I can find the place where here's that blue parabola from the first part. Here's the green line from the y equals -10. And let's take a look at the intersection points for each of those. Look, the x value is -5. Is that the same as what we had previously? Yes. And the intersection point, the other one, the x value is -2. And that is equivalent to what we had in this other case. So that is the second method that you can use to solve an equation like this. So the first and foremost way is to change this into standard form where all the terms are on one side and set that equal to y, and then see where the zeros are. It's kind of the same process. We're looking for where y equals 0 is crossing that parabola, and in this case we're using a separate parabola and looking to see where those cross. Another thing that you're going to come across in section 9, in chapter 9, section 2, is the possibility that an equation or graph has more than 2 solutions. In fact, I can see 3 different places where I have x-intercepts. One of them is here. One of them is here, and one of them is here. And they connect directly to the equation that we have. This piece right here that's factored out, x minus 3, shows us a root of, if we made this equal 0, that would be where x is equal to +3. And so there's that one right there, where we've got the root 3, 0. And then the other 2 come from this part right here. So another method would be to take this part and factor it. And if we factor what we have right here, that breaks into another couple of pieces. Yeah, so the function above can be factored into two pieces. I'm looking for two things that multiply together to make a -2, but add together to make -1. And so 1 times 2, I think it's going to work out. And if I do x minus 2 and x plus 1, I think that works. Notice that it matches the function, so they are identical. And now we can see all of the different parts. I could see my x minus 3, and that shows up right here. I can see my x minus 2, which shows up right here, and my x plus 1 factor shows up as a root or a 0 or an x-intercept right there. Okay, another task that you will have in this assignment, in this section, is sometimes you have to approximate the intercepts. Sometimes they don't land in pretty lattice points on your graph grid. As we can see here and here, they're not exactly the most beautiful. So the easiest way to do this is to, again, put the function into Desmos, and you can hover and see the values. You're going to be asked in your homework assignment to enter values to the nearest tenths place. And so for this one here on the left, I would put in, I would put in -3. I was trying to highlight it and it won't let me. Put in -3.7 because the hundredths place has a 3, which is smaller. If you recall to round to the tenths place, you look at the hundredths place, and if it is a 0, 1, 2, 3, or 4, you just truncate that. If it is a 5, 6, 7, 8, or 9, then you're going to add 1 to the tenths place and round that. For the other one, that would round because 6 is in the larger category, so I would round that to -0.3 to put that in as a solution. All right, so what if you don't have very pretty points labeled for you like that? Well, another function that graphers have is that you can use and create a table. So if I go up here and add an item and choose table, I can actually ask this to build a table. I'm gonna see if I can move this table down here to go with the function I was working on. So if I copy that and paste that in here, it wants me to match my labels. So I have a x sub 1, so I need to put some sub 1s here, and then put in a value. So if I want to have that calculate for me at x is equal to 0, that gives me a 1, and it shows in green over here on the graph. So I'm trying to estimate where that lands, and it lands, I could see, between 0 and -1. So if I put in -1 right here, I get 2. So it's not giving me, I know my value is between these two. So I need to kind of squeeze and estimate and get closer to that. So I can do that by kind of guessing and checking and getting closer. So I'm going to guess, well, what about if it's -0.5? So that gives me a 0.75. It's still a little low on here. So what if I do, my x value maybe is -0.3, and oh wow, I get really close. And so you can sort of use the table to narrow that down. So if I were to continue to do that sort of process for the left side, looking for this one right here, I could guess some values. Well, it looks like it's between -3 and -4. So here's my -3, here's my -4, putting those in the table. It looks like